Hello everybody, welcome back to another class of DS4HS. Let's get into it. So today, one thing that we're going to be going to do is pulling it all together. So everything we've learned, we're going to pull it all together. We're going to pull together using square brackets and Python functions to extract and manipulate data from two-dimensional data structures imported into the Berkeley Data Science module. And what we mean by these two-dimensional data structures are tables. So tables, that's what we're going to look at. Now in the previous video, we used square brackets to extract data from one-dimensional sequences of data, so just lines of code. And what we did, two things: a sequence of characters in a Python string data type, and then something very similar, a sequence of items in a Python list data type. So those are the two things we did: list and strings, and extract data from both of those. Now, when you think about the Python list type abstractly, you realize that it is a one-dimensional sequence of constitute Python data types. So it's just a one line, one-dimensional. Now, to be precise and exact, when you are referencing a Python list, it is best to describe that list and say it is a list of strings, it's a list of integers, it's a list of strings and integers, it's a list of strings, integers, floats, it's a list of floats, it's a list of lists, it's a list of strings. So you want to be as precise as possible, just so you can just paint a better, more detailed picture. Now, one thing that we do is we recommend that you get used to engaging in this type of abstract thinking. Get used to this abstract thinking to reveal some overarching concepts that we have found repeatedly in computer programming and in general, and more specifically, in object-oriented programming. However, one thing to not do is don't let your abstract thinking mislead you. Always be ready to validate your abstract thinking with hands-on proof, with techniques such as proof by Python. So always be ready to prove your skills with hands-on exercise, to execute code, actually get your hands on the keyboard and prove it, prove it, prove it. Always verify your abstract thoughts with hands-on validation tests. Now, let's talk about and go into more abstract thinking. So moving from one dimension of sequences, data and strings and lists, to two dimensions of data with tables consisting of rows and columns. Now, one thing we'll do in this video is we're going to build upon abstract thinking of our previous videos, so what we've gone over in the other videos. We will move from one-dimensional sequences of data, those data stored in strings and lists, and then we'll move into two-dimensional sequences with data composed of rows and columns, with tables of data, composed of rows and columns. What we're going to do is we're going to look at the following two-dimensional table-based data structures, and it's going to be two things. It's going to be a spreadsheet that you've seen before. It's going to be non-Python based example from Microsoft Excel and Google Sheets, and then the second one is going to be a Python based example from the Berkeley Data Science module, and more specifically a Berkeley Data Science table. Now, after exploring the different similarities of these two tables, we will explore using Python functions and square brackets syntax to extract data and manipulate that data from the Berkeley Data Science tables. Now let's make our theory come to life with these hands-on exercises. So let's get into it. Now, what we're going to do here is we're viewing a table of data in a conventional spreadsheet. So in this video, what we're going to do is we're going to work with a table consisting of real authentic data, displaying day-to-day expenses from a credit card statement. Generally, this data is going to be reviewed and analyzed and looked at in a spreadsheet such as Excel or slides, but let's do that right now on our remote desktop resources and open up a new browser window right here. Luckily, I have the browser window right there to take a look at our table of data in Google Sheets. Notice it's going to be a two-dimensional data, and it's going to have 4 rows, and it looks like it has about, let's say, it has about 4 columns and about 20 rows. So we have date, price of transaction. This is going to be category, but we haven't typed it in yet. And then what happened, what we bought from where. So yeah, so that's what we're going to look at. And this is from just 2 days in December. I know it says from late May to mid-March, but that was just from 2 days in December. And what we're going to look at is data that's just like that, okay? But we're going to extract it and use it in Python. So let's get into it. Now we're going to be viewing a table of data in Jupyter Lab. It is also worth noting you can quickly pull up data from your dataset in Jupyter Lab for a quick inspection before you load into Python by using keys such as Control arrow down or Control arrow up. You can quickly inspect data. So let's do that. So I'm going to do Control V, and right here, boom. So Control arrow down. Let's click it. Takes us down here and right here. So we're saying by using, excuse me, it says by using control keys such as Control arrow down or Control page up, arrow up, you can quickly inspect the data. So here we quickly inspect the data. Where is it? It's right here. There we have it right here. And then we're doing it right here. Control arrow down. Boom. I just highlighted it, and we can inspect the data by just going arrow up, down, and whatever we like. Now, let's also import our data. So we have to talk about importing our data. So importing our data using the Berkeley Data Science Library and Pandas. To load the same table of data into Python, we are going to use two world-class Python data science libraries. The University of California at Berkeley Data Science Library, it's called the Data Science Module, and the Pandas module, or Pandas Data Science Library. Pandas stands for Python Data Analysis. In this notebook, we will use the Berkeley Data Science module. Pandas is going to be featured, and we'll talk about it in later upcoming notebooks. But let's start by entering two commands to load into our data with Python with Berkeley Data Science Library. All right, so let's do it. So Control B so you guys can see it better. Boom. So where did we go? Went a little bit too far low. All right here. So here we are. So from data science, import table. Let's load the data science Python library for table. So we're just going to import table instead of importing everything from data science, just table. So that's what we're doing. And then we're assigning it to the name table. We're doing table.read_table. And we're taking that data from a file called sample credit card transactions.csv. And then we're calling table, boom, and it gives us Shift Enter, and it gives us this table. So we can see it ends in late April, and there's 183 rows because there's 173 rows emitted, and we can see that there's 10 rows here. So 10 plus 173, 180. Now, one thing that we're going to do is we're going to do table.take. Now, using the Python square bracket data slicing techniques from the previous video, let's extract specific rows of data. Okay, so here what we're going to do is we're going to take rows with the index number 10. So we're going to do 10 all the way up to 20, not including 20. So it's still going to be 10 rows because we get 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, but not 20. Okay, not 20. Okay, so that's what we're going to do. Shift Enter, and that's exactly what it gives us. So the row at index 10 is right here on the 27th. And at index 19 at the 23rd, and you can see all the transactions. So those 10 rows that we took are spread over about 4 days. And they're whole different things. They're coffee, fast food, auto, a lot of things. Now, let's view the last 10 rows of data in our sample data set. So let's do it. Let's uncomment this right here. Okay. Now remember, here we have negative 10 because we're saying from the 10th to last item in our list, from the 10th to last item in our table, and then we're leaving it empty because it's saying just go all the way to the end. So here, boom. Okay, so we have the last 10 rows of data. So that's what they are. And this ends, or it started in March 22nd. Okay, so that's what we have, last 10. And our first transaction was at the Shell Oil in Springfield, Virginia. Very interesting. Now, let's generate an error message, okay? And you guys got to tell me why this generates an error message. Boom. Remember, this error message is very long, but if you go to the bottom, you can find what you did wrong. Index 183 is out of bounds for access with size 83. Index error. So it's an index error, so remember that. But if you think about it, there are 183 rows, okay? But we start indexing at 0. It starts at 0, so really there's only 182 indexes. So we're out of range because there's not 183 indexes. There's no 183 indexes. There's 182. Boom, and that's the first day. See? First day for 1 week. Ready? Boom. First day here, okay? And then we take the last one. That's what we're looking for. Boom. First day here. So that's what we did, and it's great. because we're indexing starts at 0. Now, we're doing the same thing here. So table, let me comment these out. Table. So it gives us the entire table. Now notice the fourth column. So the fourth column is named category. So with this column, we can group our transactions by category. So we're going to do table.group. This is a data science method. And then we're going to do in those parentheses category because we want to group category. Now boom, look at that. Our most popular categories are, we have 4 categories that it groups. It groups 4 categories: auto, coffee, fast food, and restaurant. So those are our 4 categories. Now let's sort them by numerical order. So boom. So we're going ascending order from least to greatest. And our least, we spent 20 times at a restaurant and 88 times for coffee. And these 2 methods are nested within each other. That's what we do. We say group category and then sort them by the count. You can't sort them by the category. Actually, you could, but it would be alphabetical. So let's try to do that. Category. See? Alphabetical. But what we did was by the count because we want to see it in ascending order. Okay. So now let's actually graph our data and let's visualize our data. So let's check it out. Ready? Boom. Import matplotlib as PLT. So we're taking in and importing matplotlib because we want to graph. And now we're doing table.group, category.sort, and then so we're basically doing up here. So we're saying we want to look at the category and count it. So we want it to be in ascending order, and we want to have a bar chart. Okay, so that's what we did. And that .bar is a matplotlib statement. So once you know the basics of Python, the Berkeley data science modules are actually very simple to use. Notice the chaining of Python method functions on the statement. First it's group, then it's sort, then it's bar h to draw the bar chart. This is the powerful and simplicity of the data science module. So that's what it does, and it gives us a nice little bar chart. Now let's analyze a subcategory, card expenses, auto expenses only. So what we're going to do is where category is auto. Okay, so that's what we're doing. Where category matches auto. And this is really cool. So then we hit auto expenses. We give it the name auto expenses. Now let's have a look. So here, what are we going to do here? This is going to take a look at the last 10. So take is going to give us a look at the last 10. And our first auto expense was, it looks like it's mainly gas, was on March 22nd. Okay, now let's do this. Auto expense.num of rows. So it's going to show us the number of rows that we have for auto expenses and 35. So 35 times we did auto expenses. Now notice the use of the Python table method, where to extract the auto data, and then where the square brackets move around the specific table. This video is building on what we've covered in videos 3 and 4, functions, methods, and square bracket slicing. Now let's use the Berkeley data science or science table methods, groups, and sort to gain further insights into our data. So that's what we're going to do. Here, let me comment these all out so we can do it one by one. Comment, 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 comment. All right, so we're going to do the first one. Control Enter. So it's auto expenses dot group. So group descriptions and then count. Okay, so let's see what it gave us. Okay, so it says we had one time at the Exxon in Burke, Virginia, one time at the Exxon in Kings Park West, one time at the Exxon in Alexandria. So it shows us all the times we only been to a gas station once. Okay, now let's see it in descending order. So for descending order, we're going to do the same thing, but add a little wrinkle. Ready? And we did descending equals true. So it's saying do it in descending order. So from greatest to least, and equals true because it's a Boolean, which is yes or no. So our most popular gas station is the Sunoco in Fairfax, Virginia. Very interesting. Now let's make this even more descriptive. So we're only going to do descending equals true and then do dot take and then the first 6 rows. So boom, first 6 rows, 1, 2, 3, 4, 5, 6. So the 6 most popular. And then we're going to do auto expenses 1. So that's going to give us just the descriptions. Oh, excuse me, I'm sorry. Let me do that again. Shift Enter. So since we're indexing from 0, it's going to be this is the description column has index number 0 and count has index number 1. So here we're doing index 1, so it's going to give us all the counts. Boom. And that's what it did. It gave us all of our gas transactions, all of them. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 8 times 4, 32, plus 3, 35. And that's the amount of gas transactions we have. Now let's add them all up together and see how much we spent. And we can do that using the sum method. So we spent over $1,000 in gas over those 4 months. Wow. And then we're going to do one.mean. So it's going to say, hey, we're going to find the mean, the average price that we spent on gas. And that was about $31. And then we're going to do select transaction. So it's going to select the transaction column and then plot it. And then we're going to make a line graph. So boom. And then wow. So we'll see one outlier over $70. And look at it. So wow. So these are our transactions. We had some at 40, some at 3, one all the way near 80. Wow, that's crazy. Now let's check at these guys over here. Okay, so here, comment these out, comment these bad boys out. Okay. There we go. Control Enter. Okay, so it says auto expenses where auto expense is less than 70. Or sorry, is greater than 70. Is greater than 70. So that's what we did here. And there's only one time where it was greater than 70. And it was right here on March 29th. So let's look at the next one. So what this does is auto expenses dot take and then shows us the last 10 rows again. Okay, now let's do this one. -7, so it's going to show us the last 7 rows. Boom, that's what it does. And then this one's going to say dot select transaction. So we're going to look at just the transaction and exclude the last 7 and then plot it. Okay, so it's going to exclude these last 7 and then plot it as a line chart. So boom, and that's what it did. And look, no more outlier because we excluded the last 7 and that big number was part of the last 7. And now we're going to do auto expenses, select transaction. So we're going to look at the transaction and exclude the last 7 and then give us the mean. And the mean is a lot lower. Ignore this, but the mean is a lot lower. At first it was 31, now it's 29. Not a lot, but it is lower. And now we're going to do it without excluding them. So let's see the difference. 31, now it's 29. Very interesting. Now we're going to count the number of rows. So dot number of rows, it should be 35. Boom, 35, because that's how many times we spent an auto expense. Okay? Congratulations. After just 5 of these videos covering the basic Python and data science lessons inside of these Jupyter notebooks, you are able to analyze and visualize real-world data. Actual transactions from a credit card statement. In an upcoming video in Jupyter Notebook, you will analyze over 100,000 rows of heart rate data from an actual Apple Watch using the same exact concepts and skills you learned in these past 5 lessons. Now, the data science skills you are learning can be applied in so many areas, so many industries, in any sector ever. And those are investing, accounting, healthcare, cybersecurity, global warming, sports, social justice, machine learning, artificial intelligence. The possibilities are endless since every single industry and sector has a data component. Now, we are learning a new data science language within its own vocabulary, grammar, and syntax, just like any other language. You are learning a new language, an object-oriented programming-based, Python-based, data science analysis language. Just as with any language you may learn, you are learning a new vocabulary, grammar, and syntax. New vocabulary words include object, type, string, list, function, method. New grammar includes placing a function before an object and placing a function after an object using a period to call a Python method. New syntax includes when to use parentheses and when to use square brackets. So you have to learn all this just like you'd learn for any other language. But don't worry, it's very easy, especially when you get the hang of it, especially when you practice. Now in our next lesson, we're going to strengthen your mastery of this new language by reviewing some of the most common Python errors you will encounter. As mentioned in a previous video, you need to practice, and you need to be precise. When you are 99.999% right, you are 100% wrong. Our next lesson will help you adjust your mindset to be as precise as possible as we master Python for data science through hands-on learning. That's all I got for you guys today. If you have any questions, please reach out. I really, really appreciate it. You guys have a good one. Thank you so much. Bye-bye.